Okay, let's look at two examples of how we're going to use the sine rule. First, let's look at this example on the left. I've got two angles and two side lengths. I'm going to, up the top here, write the sine rule that we can refer back to. So in the last video, we got our result of a over sine A equals b over sine B, which equals c over sine C. Now, looking at this triangle here, I have a side length and its opposite angle, and then I've got an unknown side length and I have its opposite angle as well. So applying this formula, we can get that 7, a side length, divided by the sine of its opposite angle, so divided by sine of 75, is going to equal this side length x divided by the sine of its opposite angle, so divided by sine of 40. Now I've got an equation with only one unknown, so I can solve this, and the way I'm going to do that, I want to get x on its own by moving the sine 40 to the other side, which means that I need to multiply both sides of this equation by sine 40. So I get that 7 over sine 75 times sine 40 equals x. And I'm going to put that into my calculator. 7 divided by sine 75 gives me 7.247, and multiplying that by sine of 40 gives me that x equals 4.66 meters. There we go. Let's look at this example on the right. Here I've got both my side lengths and I'm asked to find one of the angles. But we're going to apply the formula in exactly the same way. Let's start first with the ratio A over sine A using the side and the angle that I know both of them. So I've got 12 centimeters is the side length, opposite an angle of 130 degrees. So that means that 12 over sine 130 is going to be my A over sine A. And that's going to equal B over sine B, where my side length is 3 centimeters and my angle is unknown, is x. So that equals the side length 3 over the sine of x. Now I need to rearrange this. First I'm going to rearrange it to get sine x on its own. And the way I'm going to do that, there's, if you remember, we spoke about when I have the unknown on the bottom of a fraction, there's two ways of thinking about this. Either I can think of it as flipping both of these fractions to get sine x to the top, or I can think about it as moving sine x over to that side. I'm going to do the first option. I'm going to flip both fractions. So I get that sine of 130 over 12 equals sine x over 3. That's much more helpful because now I've got my unknown on the top of the fraction, so it's a lot easier to work with. Now I need to get rid of that 3, which I'm going to do by multiplying both sides of the equation by 3. So I get that 3 times sine 130 over 12 equals sine of x. And now I've got my sine of x on one side of the equation and all the other stuff which I know on the other side. So I'm going to work out what this other stuff actually equals. So I've got 3 times sine 130 divided by 12. And that gives me 0.1915. So sine of x equals 0.1915. Now, I'm looking for an angle. I have this number, sine of x equals this, and I'm looking for my angle, which means I need to use inverse sine. So inverse sine of 0.1915 equals x, which again I can just put into my calculator. So inverse sine of 0.1915 gives me that x equals 11.04 degrees. So we've done an example where we have a missing side length that we're trying to find, and we've done an example where we have a missing angle that we're trying to find. You can look back at both of those when you're solving those types of questions and follow those same steps to arrive at the answer. That is the sine rule. In the next videos, we're going to move on to look at the cosine rule.